Control of all aircraft, whether fixed or rotary wing, is accomplished through movement of control surfaces. The larger the aircraft, the larger those control effects must be, requiring stronger control systems to move them. This is particularly true in heavier rotary wing aircraft, where, in addition to the forces caused by aerodynamic effects related to lift, drag, thrust, and gravity, spinning rotor blades and associated rotor head components generate tremendous centrifugal forces. These forces tend to feed back into the flight control systems. In the H-21, full mechanical control can be maintained. The strength required to operate it mechanically would make it difficult to sustain flight of long duration. You can see how hard this man is working to move his cyclic control stick. Addition of collective pitch, difficult in itself, makes movement of the cyclic control stick even more difficult because of the added lift gravity forces to be overcome. To reduce the amount of physical effort required to operate these flight controls, heavier helicopters use hydraulic boost systems. Now watch the difference when the hydraulic boost is put into operation. Words are not necessary to explain the difference. You can see it. Notice how easily the blades are tilted. Nice and easy now, isn't it? Instead of using his own muscles, he's using the helicopter's hydraulic muscles. This is one of them, one of the 4 hydraulic servo actuators used in the H-21. It is similar to those used in all helicopters having hydraulic boost systems. Hydraulic fluid is pumped to those servo actuators under pressure. Movement of the cockpit control operates the pilot valve, which directs the fluid to either side of the actuator piston. The hydraulic pressure on the piston is transmitted through linkages to the upper flight controls. The power output of these servo actuators is considerable, as this simple demonstration will indicate. There is no trick to this. The strength of the man on the left has nothing to do with it. He's not pushing the big man. He's operating a valve that lets the hydraulic pressure do the pushing. Here's how the H-21 hydraulic flight control system works. It is similar to most hydraulic flight control systems. The major components are a reservoir, pump, pressure relief valve, accumulator, air pressure gauge, hydraulic line pressure gauge, shutoff or selector valve, line filter, servo actuators, return filter. The reservoir holds the necessary supply of hydraulic fluid. Next is the hydraulic pump, which supplies pressure for the system. It is rated at 1,000 pounds per square inch pressure at 1,650 RPM. Fluid is driven by the pump through the pressure relief valve, which limits the maximum pressure in the system to 1,150 pounds per square inch. The accumulator acts as a shock absorber for the system and maintains fluid under pressure for intermittent excessive demands of the system. Inside the accumulator, there is a floating piston which divides it into 2 chambers. One chamber is filled with air to a pressure of 300 pounds per square inch. When fluid under pressure from the hydraulic line forces the piston back against the air pressure becomes equal to hydraulic pressure in the line. In this case, the maximum, 1,150 pounds per square inch. Whenever the system calls for additional fluid under pressure, the accumulator makes it available, creating a corresponding drop in system pressure. In this case, 500 pounds per square inch. And when fluid flowing through the system is stopped, instead of pressure backing up into the system creating surge pressure, it is absorbed by the floating piston and air cushion in the accumulator. Fluid is directed through a micronic filter, which protects the valves, passages, and highly machined interiors of the servo actuators from damage due to contamination by foreign particles. The shutoff or selector valve is a modified four-way valve, which in the off position connects the actuator pressure ports to the return line and prevents hydraulic lock so that the controls can be operated mechanically. Each of the four servo actuators has two ports, one for pressure fluid and one for return. As actuator pistons are moved one way or the other by fluid under pressure, fluid from the opposite side is forced into the return lines. Returning fluid passes through a hydraulic system filter, where it is cleaned again before replenishing the supply in the reservoir and is available for further pumping through the system. A hydraulic line pressure gauge is located in the cockpit near the shutoff valve and reads in pounds per square inch. This gauge is connected to the hydraulic system anywhere between the shutoff valve and the servo actuator. In the H-19, there are 3 flight control hydraulic servo actuator units mounted on the main gearbox. Mechanical linkages from the cockpit controls actuate the pilot valves of the servo actuator and allow hydraulic fluid under pressure to enter the actuating cylinder and open a port to provide a return passage. In the event of hydraulic system failure, the mechanical linkage itself can operate the controls. One servo actuator controls the fore and aft movement of the star assembly. The other 2 servo actuators control lateral movement. All 3 servo actuators are operated by movement of the collective pitch linkage through a mixing unit, so that collective pitch can be varied without affecting cyclic pitch. The H-25 also uses 3 servo actuators. All are located under the floor. One located forward operates the lateral controls. The other 2 are located just aft of the cockpit. When facing forward, the one on the left is the longitudinal servo actuator. The one on the right, the one the repairman is removing, is the collective pitch servo actuator. An important thing to remember when removing a servo actuator is that although the ports are marked for pressure and return, the pressure and return lines are not. Therefore, both lines should be tagged to make sure of proper connections when a new servo actuator is installed. As you've already seen from looking at the trainer, the H-21 uses 4 servo actuators for hydraulic flight control boost. As you see them here, the one on the bottom is the longitudinal servo actuator. Above it is the collective pitch servo actuator. Next above it, and mounted crossways, is the lateral control servo actuator, and the top one is for directional control. Applicable tech orders contain troubleshooting charts to help the repairman in determining the causes of most common troubles. But some procedures are common to all hydraulic flight control systems. Be sure to remove all system pressure before disconnecting any hydraulic line or before filling a hydraulic reservoir. Whenever a new unit is installed or the lines have been opened up and reconnected, the system must be inspected. To do this on the H-25, the engine must be running or an auxiliary source of hydraulic pressure be connected in the system. Turn the shutoff valve to the on position and operate all of the flight controls so that hydraulic fluid will be pumped to all parts of the system. The collective pitch stick and cyclic pitch stick must be moved through the limits of all flight attitudes. Effective control of helicopter flight could be achieved without hydraulic boost. but the necessary increase in size and weight of bell cranks and quadrants to accomplish this would be undesirable. Hydraulic servo actuators are small, light in weight, highly dependable, and capable of power outputs well beyond the requirements of flight control systems. Hydraulic flight control systems are simple in design, and their operation is easy to understand. Generally, they consist of a reservoir, which contains the system fluid supply, a pump to supply system pressure, a pressure relief valve and regulator to maintain proper system pressures, and accumulator to absorb system shock or to aid operation in either overload or underload conditions, a selector valve to cut off pressure in the event of malfunction, one or more filters to protect the system from contamination. Yes, hydraulic flight control systems are simple in design and easy to understand. All of the components are rugged in construction, easy to maintain, and accessible for removal and replacement. It is most important that the helicopter repairman acquire a thorough knowledge of the operation of each and every component, so that the high degree of dependability designed into these hydraulic flight control systems is not lost through improper maintenance.